Alright, g'day guys, I'm kind of back. So I'm about there, and stretching I'm about there. So yeah, I'm sort of working my way up to this. So not that I want to put my hand up for the teacher. This is a two-part video. Remember me a while back and I was saying that I wanted to try the weld processes out. So I've done that. I've shot up to the boat. I tried the welding with the wire that I wanted to give it a go, and I had no luck with it. So I came back home, did a few searches, and I've done some weld pieces. Then what I did was I broke those weld pieces to see which process was going to be the best and safest to use. So unfortunately I won't get to that part in this video, so you'll have to wait for the next episode. It's taught me a lot. There's an old saying, I'll have forgotten more than what you'll ever know. Yeah, that really came into context. So I remember someone saying it to me years and years ago, and I had no idea what they were talking about. So this video is quite long, just be prepared for that. There's a fair bit of explanation in there. Normally I wouldn't care about it, but it really needed to be to put everything into context with what I was trying to do. Alright, I'll just kick on with the video. I'll just kick on with the video. So sit back and enjoy. Cheers. G'day guys, I'm back on the boat. Yeah, been waiting for this day. So I've been tacking all the steel work for the boat together with a process called manual metal arc, which most people know as stick welding. At the moment the MIG welder's got solid wire in there, and I want to change it over to a flux core. The flux core has its own gases in it, so as the wire melts, it creates a gas, so I don't have to add any additional gas, whereas if I was to use the solid wire I would. So in order to do that, what I also have to do is I have to change these rollers. So we'll just take this old roll out. Just wait for him to come through to there. Come on. There we go. I'll take this off. So this here is solid steel wire. So basically it's a solid steel. It's got a small bit of copper on the outside of it. They put the copper on the outside, like it's microscopic thin film. They put it on the outside to give it a little bit better conductivity as it hits the contact tip. So when you're using solid steel wire, you use a roller with a V in it to grip the wire as it goes through. You can press the other side with another roller identical. When you're using a flux core wire, because the wire itself is so soft, when it goes through the rolls it squashes a little bit, and basically you need these knurled rollers to help push it through the liner up to the MIG torch. So I'll just put our knurled roller. We make sure that we put the 0.9 to the outside. So the wire I'm using is a 0.9 of a millimetre thick. So these rollers have their own markings on them, so that's 1 millimetre, that's 0.8 millimetres. This one is an A 1 millimetre, which means that that is actually a U shape instead of a V, and on the other side is 0.8. And on our other rollers that we pulled out, we have 0.8, 0.6 for solid steel in a V, and we have 0.6. So just different rolls for different sizes and different types of wires. I keep these in here so that I never lose them. So on top of that, in the end of our MIG torch, we have a contact tip. So basically what happens is the wire feeder feeds the wire down. It gets right through to the contact tip here in the end. So the contact tip just screws in the end there. So the wire runs through this. The electric charge is added at this point to the wire, and then it burns back to the tip. So, alright, these ones are 0.6. because I used to use this welder for doing car panels, and the one that's in it at the moment is a 0.9. I'm just going to put that tip back in it for now because it's there's probably nothing wrong with it, so I'll just wait until it stuffs up. Now this here is called a shroud. So basically what this does is it directs the gas flow out over the weld or over the heated electrode. And so what you do is you put this on to guide that gas. Some problems that you get with these is they get clogged up with spatter, and next thing it starts to create turbulence and you end up with porosity in your weld. But it doesn't matter for us at the moment because we're not using that process. The process we're using doesn't involve any gas, so I don't even need to use this. I still might because it's been a while since I've done this sort of welding, and basically what it'll do is it'll help me protect the tip a little bit. Okay, so when you put this wire in, basically you want the wire to come off in the direction of the rollers. So make sure that you put your reel in the your spool in the welding machine so that as it comes off it peels straight into the machine. We'll line that up. Push it through a little bit to get it started. I don't actually have any power onto this machine at the moment, so I'm going to back this tension off just a little bit because the knurls on this roller will put marks in that wire, and then as it comes through into the contact tip it's more than likely to get jammed, and then it will burn back onto the contact tip and start to give me trouble. This area is fairly rusty from sitting so long, so I'm just going to quickly give it a clean up with the grinder to take a bit of the rust off the top. And down this line here there's also not enough penetration gap in there, so I'm just going to have to V that out a little bit with the grinder. Well, I really have no idea how many amps I should be using this stuff with, or anything like that, because it's the first time I've tried it. So basically we're just going to wing it and see how we go. That there's 19 volts, probably a little bit hot for that gap, so I might turn it down to 17. Oh, that's shit. I mean, that's really bad. Ah, it's much better. Generally, I'm pretty happy with how this wire's performed. I've got to go and read up on it. There's a couple of things that I've found with it. So basically you can see all the spatter that's in this area, just around where the weld was. I don't know why that's the way it was. It may have something to do with the wire speed setting, but I'll have to check that out. And the other thing is, I'm not sure if the camera's going to point it out, but from here to about here there is a crack in the weld. Usually that sort of crack is typical of a 211 wire, which is what this stuff is. So I just need to go and have a bit of a read up on the safety data sheet on how to correct it. This one here, I've had a lot of people talk to me about this. So basically, I've had to square join some sheets together. So that's one sheet, that's another sheet, and that's the main parent sheet. So what I did to combat, or to make sure that I'm going to get enough penetration in there, is I welded across this path first, right the way along, and then I went back through and I got the grinder and I gouged that out with the grinder. So now that's left that right open back to the root, and so what I can do now, what I did then was I put wire out straight over the top of it. That's just going to stop this from cracking out in the future. This here is concerning me a little bit, but we'll get on top of that. Yep, so I'm pretty happy with how this wire performed. So this is the underside of where I just welded inside the boat there, and have a look at that for penetration. That's pretty sweet. Pretty typical of that type of wire though. Yeah, that's pretty good. That's really, really nice penetration on that. Minor bit to clean up, a little bit of a back gouge, and then a pass over the top to tidy it. Okay, so as you saw, the welding on the boat wasn't very successful. So what I've done, I've come home and I've pulled up on the internet the problems that I was having, and the Google searches that I found basically didn't show very much that I didn't already know, except for one thing, and that was the polarity that I was using on the wire. So I didn't even think about it at the time, but this OSFIL 11 is a negative or electrode negative polarity. Now when you use it the opposite way, you get a lot of spatter and you get cold short, which is a crack as something's cooling down, or it's more prone to cracking when it is cool. So which is ideally what you don't want in a boat. Now this OSFIL 11, it is a gasless wire, so you don't need any shielding gas. All the gases created to shield the molten whirlpool are created from the flux burning that's moulded into the centre of the wire. So there wasn't any problem there, but what was happening was the electrode wasn't actually getting hot enough to burn the gases correctly, which meant that it was just spraying out all the molten metal from the electrode, which made the spatter, and the crack was caused because the polarity was the wrong way around, and it wasn't heating the metal up enough to put it down onto the material. So what I've done, I've brought it home. I'm just going to try out the few processes. So I'm going to try out the flux cored wire, the OSFIL 11, and I'm also going to try out the T16 welding rods, which are a low hydrogen welding rod. So I'm going to do a few things. First of all, I'm just going to trim this piece of plate up into smaller sections so that I can get a reasonable size weld piece. And then I'm going to try both processes of welding. Now I'm going to do them in position. So I'm going to do them as if this was the hull of the boat. So I'll start on the inside, I'll do a root pass, I'll do a cap pass, I'll go back to the underside, and then I'll do a grind out, and I'll do it with both the wire and the electrodes. Once I've done that, I'll do a cut through them, and I'll then put it in the vise and bend it over and see if either of them crack. And then the other thing that I'll do is I'll put a nick in each side and bend it over and see exactly where it breaks on the material. Basically a destructive test of the weld procedure. So Alright, I'll just get this all trimmed up and then I'll set it up here in the vise so that I'm welding it in position, and we'll go from there. So this is the weld prep I'm using in these. It's called a square butt joint. So basically I'm not putting any V-prep on them. I'm just butting the two plates together like this with a 3mm penetration gap, and then I'll put a root pass down and then a capping pass, and then I'll back grind on the opposite side, and then I'll just put a capping pass on there. So this is a standard cutting wheel. Nowadays you can get ones called thins that are 1.25mm thick. This one here is double that. So basically I'll just put it in there in the gap. I'll put a tack here and a tack here, and that'll give me my ideal penetration gap. Okay, so I'm pretty happy with that weld. I was a little bit worried then that I'd put a bit of undercut in that area there, but I haven't. So I'm just going to break this off and cheat a little bit because I don't feel like grinding up underneath there. And I'm just going to grind it, and then I'll put it back in position, and then I'll do the overhead weld. So don't forget, I'm simulating this actually being inside the boat. So I've just ground that preparation back, so I've ground it from the opposite side. This is what I'm ended up with. You can see that it's a consistent weld all the way through. The only thing is I didn't quite get as much of the way through with the penetration that I'd hoped. Okay, so there's our completed weld. That's the top side. That's the top side, and that's the bottom side. Now, one thing I'm trying to do is to get a reinforcing cap. So you can see how there's a gap now in the ruler as it goes up over the top of the weld. Well, that's a reinforcing cap, shows that the weld's got a reinforcing cap, and the same on this side. So that was one done down hand, and that was the overhead weld. Okay, so now we're switching over to the manual metal arc. Now the electrode size that we're using is a 3.2mm, and its current range is telling us we need it between 90 and 135 amps. So now what we're doing a penetration gap, so I'll probably sit around about the 95 amps. It's a little on the low side, and then when I go to do the capping run on the overhead, I'll turn the amps up to around about 110. Okay, so you can see there the penetration that I got out of the manual metal arc or the stick welding is a lot more than it was out of the flux core. So that side of it for a first pass, I think that was better than the flux core. That's a very sweet looking weld though. Condition on that's much better than the flux core. I've got probably a millimetre reinforcing cap on that, so that's very good. Alright, let's do the overhead side of it. Overall that went pretty well. There is some porosity here at the start of the weld. That's because I was too far away with the rod at the start. and also I didn't preheat these welding rods. For my next one, it's going to be stick down hand on the top, and then from the underside I'm going to use the flux core wire. What I am working up to is using solid wire with the MIG on the inside of the boat where there's no wind, and then on the outside flux core wire. So I haven't bought any gas at the moment. I don't want to buy gas just yet. I'm not up to that stage, so until then I'm just going to continue to use stick on the inside, and I'll use the flux core on the outside, and it's more about a speed thing than anything else. Alright, so I've background that first pass. So all I did there, I just did a stick weld on the top side with that 3mm gap between the two plates. I've background it, and now I'm going to put it in the overhead position, and I'm going to weld it with the flux core. Right, so unfortunately, because of the length of that video, I've decided not to put the testing in this week's video because it takes a bit of time in itself, and the outcome is actually quite surprising. I didn't expect the results that I was getting out of that. A few things I haven't put in there was the actual times that it took me to do each of those welds, and believe it or not, the stick was much faster than the MIG process. So I hope you got a bit out of today's video. You can see how I've set the pieces up, and you've seen what I've done to get them ready. So in the next episode you'll see me bend them. So basically I put a bend in one, and on another one I put a nick in the other side, and then I crack it with a hammer until it snaps, and that gives me the result that I've been looking for. So yeah, and they are, as I say, they are quite astounding. So I'm just going to leave it at that. All right, until next week, have a good one, stay safe, cheers.